And let's look at two more. Let's do 3n squared plus 18n plus 24. But my question is there a GCF here that we could factor out? GCFs are always easier if you'll take them out first because it's going to make your numbers a lot smaller. And I see a GCF. Do you see it? What do they have alike? 3. Yeah, so let's take out a 3. Now, the 3 is not gone. It is part of the factor tree. You know, 8 is 2 times 2 times 2. I can't just drop one of those 2's off and say it's 2 times 2. You can't drop a factor off. It's part of the factor tree. And I'm going to have n squared plus 6n plus 8. Now we'll do what we did in problems 2 through 4. Now let's do our binomial. Don't try to go from this step to this one. You don't factor that way. I would never, ever try to go from here to here. I'm going to question you if you do that because it's like, where's all the work that you're doing in your head? This one's not that hard. Some of them can get pretty crazy. N squared, n and n. 8, 1 times 8 and 2 times 4. Which set adds to my 6? The positive 2 and the positive 4. The whole factor tree is all 3 of those factors. Number 6, 2r squared plus 8r minus 120. GCF 2 r squared. I mean, I don't mind doing factors of 120, but it's much easier to do the factors of 60. 2r squared plus 2 parentheses r squared plus 4r minus 60. And I'm going to do my factor tree here. Actually, I'm going to do this. I'll go ahead and put my r and r. Now, what about signs before I get the signs? How can you multiply to be a negative? One has to be positive and one has to be negative. And I don't usually put them on there yet. Now, in this case, because they're both 1r and 1r, it wouldn't matter. It can matter when you have different numbers. So I usually don't do that. Let's go over here, and I want you to list all the factors just to see where we are. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. That should be the... Now recognize that we're adding them where one of them's positive or negative. Now you can still look at it where it's like a 1 and a 60. If one of them's negative one way or the other, it's going to give you 59 or negative 59. It's not going to give you a 4. So I'm interested in what the subtraction is. We'll get the sign. And as you go down through here, that's 28, that's 17, that's 11, that's 7, and there it is right there. Now, write this on your paper. Negative 6, positive 10, positive 6, negative 10, because this is what a lot of people miss. What's the combination that will give you the positive 4? Negative 6, positive 10. So be careful. That's one of the common mistakes that I see. So those are all pretty straightforward. Now, let's do difference of two squares, which goes pretty fast. When you're doing them, they're easy. It's when one pops up every once in a while that you're like, oh, I don't remember it. Just one of those things, you know, when they're listed on a quiz and you've got them, boy, you can kick them off real quickly. When it says difference, that means subtracting. It's not going to be a trinomial because it only has 2 things. It's a binomial. And squares means perfect squares. What do we mean by that? Okay, so 25 is, 4 is, 9, 16, 25. You see where we're getting them? Now, don't forget about 1. We tend to leave that one off. 1 is perfect everything. It's perfect cube, a perfect fourth, it's perfect fifth. You can take any root of 1 and it's going to be 1. It's kind of an interesting one. So let's first recognize what it is. X squared minus 49. If you look back at that last example we did right above our factoring before we did the GCF and all that, factoring them is pretty easy because when you put them together, the middle term's got to go away. So x squared's got to be x and x. And it's a perfect square too, by the way. That's the only one we're looking at right now. But actually, x to the 4th is, x to the 6th is, if you want to kind of add those, because those will come up later. And then do you remember how it factors? You take the square root of the 49, which is 7 and 7. It's a quick one. But what happens to the signs?
One of them's positive and one of them's
One's positive and one negative, because when you check it, the plus 7x and the minus 7x add out where you don't have a middle term. It's actually 0. Your middle term is actually 0 x's. Number 8, x squared minus y squared. They can be variables, square root. I always do them that order. I don't do x, y, x, y. I usually go x, x, y, y. One's plus, one's minus. Doesn't matter which way you put it. Number 9, 36m squared minus 1. And that's why I added the 1 up there, because sometimes people forget that one. So perfect square, they're both perfect squares. So the square root of 36m squared will be 6m. And the square root of 1, I always do the plus first. Okay, one more. 18n squared minus 32. Are those perfect squares? No. So what's the first thing I might look for? Is there a GCF? 2, is that going to be the biggest one? And it actually is. If you do their factor trees, all they have is a 2 in common. And so you're going to have 9n squared. See what happened? And you'll have 16 right here. So it's kind of nice. It did give us a difference of 2 squares. If it had come out like 9n squared minus 15 or something, you would stop. It only had a GCF. So square root of 9n squared is 3n. Square root of 16 is 4. One on plus, one on minus.